Hello guys, in today's class we shall discuss about current transformers. They are also called as CTs. Okay, let us see what current transformers are. Current transformers are those which are used to obtain reduced current signal from power systems. Means which is going to step down the current value from higher to lower. Okay, you should not understand like step down means voltage. It is going to step down the current value from higher to lower, so as to measure, control as well as the protect the system. Okay, so these are three things which we are going to use the current transformers. First one, to measure as well as control as well as for protection purpose, we are using what? Current transformers. Basically, like I told you, it steps down the current value from high to low for operation of relays. The reason is because relays and other instruments are operated at low current values. So in order to reduce, in order to match the configuration of relays, your current transformer is going to what? Step down the current value from high to low. Not only just relays, even your instruments connected at the secondary winding of your current transformer also require what? Less current value. So current transformers are boon for us. Not just your current transformer reduce current value from high to low, it also, it's a major thing, or I can call it important thing. Current transformers also isolate relays from high voltage at primary circuit. As we know that current transformer is going to step down, and not only just reducing the value of the current in the secondary side, it also isolates the high voltage at the primary circuit, so that lower voltage can be supplied, or lower voltage in sense what? In terms of lower current value is supplied to the instruments or relays connected at the secondary side. So thus allow the used for standardized current ratings around 5 or 1 ampere. These are the current values at the secondary side. They come in between 5 or 1 ampere. This is what the standard ratings are of the current transformers. CTs are, that is current transformers, are designed to withstand 50 times the full load current. Just imagine, around 50 times more. That is say full load current is around 5 ampere means just it's a case, so it will be around 250. Yes or not? 250 amperes, more than 250 amperes it will withstand. Just I'm taking a case. Okay, for few seconds, it is not for an hour or something. For few seconds it will withstand even the current reaches more than 50 times of the designed actual value, the rated value. So the measure of current transformer performance and its ability to accurately produce current in the secondary side. So this means whatever the current transformer we have designed, so it should be able to reproduce the required current in the secondary in proportionate to the primary value. Okay, so whatever instruments we are going to connect is connected at the secondary side, and whatever the value the current transformer is going to produce, it should be in contrast, it should be in the ratio proportionate of your primary value. Okay, so CTs are required for metering as well as instrumentation purpose, and they should be accurate over normal working range of currents. This you all know, yes or not? So current requirement for relaying should give correct ratio, like I told you. Okay, so CTs used for relaying are designed to have small errors. Here whatever the designed current transformer is made of, we have very less errors here, you can see. Okay, so CTs used for relaying are designed to have like I told you this earlier, so during fault conditions. Okay, so current transformers are used for relaying so as to design for small errors, and also during the fault condition. So during fault condition the errors are very less. Okay, we know that no instrument is foolproof, so here some amount of error is there, but errors are reduced here. Okay, so accuracy of current transformer is defined by the formula here, that is NIS minus IP whole divided by IP into 100, where N is the nominal current transformer ratio, which you already studied. This is a transformer ratio, and it can be given by rated primary current, that is primary current if it is IP, and the rated current secondary current is IS, so it is IP by IS. Similarly, one more formula we have, it is number of secondary turns divided by number of primary turns, that is N2 by N1, N is equal to, fine. and where IS is secondary current, S stands for secondary and P stands for primary, and IP is your primary current. And again, the ratio error of the current transformer depends on the exciting current of the particular transformer. Okay, that you need to remember. Okay, so we have three different types of current transformer. First one is electromagnetic type, second one is optoelectronic type, third one is Rogowski coil. So the third type. So let us see the first one, that is electromagnetic type. So electromagnetic type, again it is divided into two parts, means again we have two types in that is in electromagnetic. The first one is bar type and the second one is wound type. Okay, second one is wound type, first one is bar type. Okay, so in the bar type, what specialties we have, what exactly it looks like, means in terms of description we can understand this. Anyhow, we are going to learn about more such things in detail in coming classes and all. As of now, we are going to take little of the knowledge of these current transformers. So bar type, the first one of the electromagnetic CT, it does not have any primary winding. Okay, it doesn't have any primary winding. Instead of primary winding, it has straight conductor wire, that you need to remember. There is no any primary winding. Instead we have what? Straight current, that is straight conductor wire, which carries primary current. Okay, so one thing you came to know, that there are no any primary winding and all, as usually a traditional transformer we have. Yes or no? Traditional transformer we have primary winding, secondary winding, as well as tertiary winding. That is again for 3-winding transformer. But here we don't have such any primary winding, as well as instead of primary winding we have a straight conductor wire, so which carries your primary current. Okay, so ring type core is utilized here. So ring type core is encircled on which secondary winding is wound or over the periphery. Okay, ring type core. Usually we know, right? Traditional transformers we have like U-shaped core or T-shaped core. Yes or not? Depending upon shell or core transformer. Here we are having ring type core, a circle one, on which secondary winding is wound over the periphery. So I'm going to take the core, which is the form of circle. On that I'm going to wound your secondary winding, so that it is wound over the periphery. Okay, so this is how the in terms of construction your bar type looks like. Okay, so here first of all you need to remember, we don't have any primary winding. Instead of primary winding we have a straight conductor which carries your primary current, that is your primary part. And the secondary part is what? Your core, that is over the core we are going to what? Wound up the secondary winding, and again it is in the straight conductor, like I told you earlier, that is placed at the center of the your core, ring type core, so that whatever depending upon our needs, the current is signaled to the low value. So you can clearly see the bar type current transformer here. Like I told you, there are no any primary windings. Instead of primary winding we have straight bar over here. Yes, this acts like your primary winding. Okay, and over that we have a core here which is encircling your primary winding, and over the core I'm going to what? Wound the secondary windings. Okay, and again this secondary winding is connected in series with the ammeter so as to read the current flowing in the primary at the reduced form, Okay, this is what we have with the bar type current transformer. And the second one is wound type current transformers. So let's see that. Here we have both primary winding as well as secondary winding, the wound type, but one change is what? We have very less primary winding in number of turns, that is fewer number of turns are present in the primary winding. So usually it is wound on the iron core. I shall show you that diagram later. First you just listen this. That is your wound type current transformer has both primary winding as well as the secondary winding, but primary winding turns are very less when compared to that of your secondary winding. So again the windings are wound on the iron core, and that is inserted in series with the conductor which is carrying the measured current. So here you can see the diagram how it looks. You can see this is the magnetic core and this is the diagram of your wound current transformer, and over this I am going to what? Wound the primary winding as well as the secondary winding, so that your and again it is connected in series with the conductor, that is primary winding is connected in series with the conductor where your measured current is going to measure. Okay, that is with the conductor carrying the measured current. And again in the secondary winding you can have any step down value of the current. Okay, so the primary winding is connected in the series with the circuit where you are going to measure the current, and the secondary winding is there over here, which shows you the reduced form of the current in the secondary winding. It is much so it looks somewhat like this. See, it is one more way of representation of your own type current transformer. You can see here. Okay, so you can have, there is only secondary turns in shown over here, that is S1 S2, primary windings are hiding here, but remember primary windings are less whereas your secondary windings are more, and primary winding is connected in series with the conductor where you are supposed to measure the current, and again with the help of secondary winding you can connect in series with your ammeter as well, so that you can measure the secondary current. So this is what we have with the wound current transformer, wound type current transformer. Okay, and the third one that is a Rogowski coil, that is ROGOWSKI. Okay, Rogowski coil. So again this again you're going to deal that is learn in detail in coming classes. So just as of now, for the basic knowledge sake, just remember it's a helical coil of wire. Okay, the whole assembly is put over the straight conductor whose current is to be measured. Okay, very simple, in simple narration they have explained here. So basically it is made up of a helical coil. Again this Rogowski coil you're going to learn in again your high voltage engineering. Okay, in detail more there. Here only general information is given, that is it is made up of helical coil of wire. Okay, and the whole assembly of your Rogowski coil is put over the straight conductor, just like your bar type of electromagnetic CT, so as to measure the current whose current is to be measured. Let's see how it looks like Rogowski coil. Okay, see this is your Rogowski coil here. You can see this is the helical, like I told you, this is the helical wire wound over the primary conductor. Actually it is a straight conductor whose current is to be measured. Again you can see this helical coil which is encircled circle fashion. Again it is given to the operation amplifier so as to amplify the current value as per the desired. So whatever output will be produced here, it will be in proportionate of the current flowing in the primary conductor. Okay, again here also there are no any turns primary winding, but we have secondary winding here. It is called as Rogowski coil. And one thing what you need to remember is there is no any core over here. Okay, there is no any core. Directly it is a helical wire which is wound upon the wound over the primary conductor. Okay,